Experts fear that without conservation efforts, the endangered species could disappear from the wild by 2002. Just 100 years ago, there were at least 100,000 of this endangered species. By 2010, the estimated world population was 7,800. The bar graph shows the estimated world population of this species from 1970 to 2010. And then there's a graph of a polynomial, and we're also given the polynomial of the function. We want to find and interpret f of 40. So we're going to replace x in the function with 40. Every x will be replaced with 40, and we are going to calculate the result. So if you were showing how you got your answer, this is the work that you would show. And you would let your calculating device do the rest of the work. I'm going to use Mathematica. So I'll adjust my notebook. And I'm going to use the numerical approximation function, which is referred to with a capital N. And Mathematica uses brackets where we would use parentheses for a function. So I see that this calculating device gave me 7,793. That's actually not an approximation. That's actually an exact result. So going back to the problem, this tells me that in the year 2010, 40 years after 1970 is 2010. So in the year 2010, the polynomial estimates the population of the species to be 7,793. All right, so I want to identify this information as a point on the graph of f. So we saw that for the function, the independent variable, the variable values that were on the horizontal axis, were the years after 1970. So 2010 is 40 years after 1970. So this independent variable value for this point would be 40, the number of years after 1970. And then the 7,793 is the dependent variable value. So 7,793 is the second coordinate. 40 is the first coordinate, if I were to represent this as an ordered pair. So does f of 40 overestimate or underestimate the actual data shown by the bar graph? By how much? So if I look at the bar graph, I see the bar graph told me this population would be 7,800. And the polynomial told me it would be 7,793. So the polynomial function for x equal 40 since 7,793 is smaller than 7,800, underestimates the population size by, and when I subtract 7,793 from 7,800, I get 7. So it underestimates the population size by 7. The difference between those two numbers is 7. And that 7 is an underestimation. Now I want to use the leading coefficient test to determine the end behavior to the right for the graph of f of x. Will this function be useful in modeling the population of this endangered species if the conservation efforts fail? All right, now notice if the conservation efforts fail, the population is going to continue to decrease. Notice this graph begins to increase on the right end. So the graph will rise to the right and therefore, thus, will not be useful if the population of this endangered species continues to fall. So D would actually be the best representation of the answer.